Okay, so let's start this session. We have a long session ahead of us today. I hope you enjoy. My plan is to start now. As I mentioned, you will be mute all along the session. However, you can ask your questions using the chatting box. Redirect your questions to the user, their use company. I'm not logged in the system under my name. So I think most of you already know me. I am Jose Fuentes. I am the Chief Operating Officer of their use company. And this is the plan for today's session. 3-hour session, as I said, starting with a brief introduction to their use company. Then I will go right to the point of requirements quality by mentioning what could be the impact of poor quality requirements in your projects. And I will also highlight some basic concepts. Then after this introduction, the main block will be about quality rules for requirements. This is a kind of theoretical 1-hour session where I will be describing the most common quality rules to assess and analyze the quality of your requirements. This session will finalize with a question and answer session before the break. Then after this question and answer, we will have a well-deserved, I hope, 15 minutes break. And the second part of the session will be an intensive demo, a walkthrough the tool. You will see the main tools in the Systems Engineering Suite. So I will introduce the suite, and I will walk you through the RQA Quality Studio, the RAT authoring tool, and the Knowledge Manager as the 3 main tools within the suite. Then everything will be finalized with 15 minutes question and answer. I will introduce and provide you some conclusions and additional notes. And we have, as I said, the final question and answer session, right? Anyhow, please don't hesitate to ask your questions all along the sessions. I will be receiving all these questions in the chatting box, and in these 2 slots for question and answer, I will go back and check all the chatting box, including all the questions you might have asked. So let's go right to the point with the introduction of the use company. Our company is based in Madrid, providing a knowledge-centric approach to leverage system engineering activities in our customers. The company was created in 1999, so over 20 years now, as a spin-off of our university here in Madrid. It is made up of a nice combination of people from different roles and standpoints, like systems engineers, software engineers, artificial intelligence people, and natural language processing. So we all are conforming a very nice team, capable of offering you these tools and techniques and approach and services that I will be mentioning today. Our headquarters remains in Madrid from the very beginning, with 2 international offices, one in Stockholm, Sweden, and another one in Tokyo, Japan, offering this a knowledge-centric approach, not only for the quality to analyze and enhance the quality of your requirements, but also to other topics like the ones I will mention in this slide. So the use company, we like to have it short in an acronym, TRC. TRC is not only the acronym for the company, it is also that if you allow me a small change, because in Spanish, quality is spelled with a C, while probably in the rest of the world, quality is spelled with Q. So if you allow me a quick change here, then I can say that we apply this knowledge-centric approach to T for traceability, R for reuse and reusability. This was our first and main topic, and this is why we are having this reuse company name. And then quality, so T, R, and C or Q for quality. So these are our 3 main topics. However, today I will be focusing clearly and uniquely on requirements quality. Some of our customers within the field of requirements quality are in these mainly four industries plus the final block, starting mainly with aerospace and defense with companies like Airbus or Safran, Thales, Hensoldt, AES, or the Ariane launcher, Ariane Group. This is still our main industry, aerospace and defense. I am not authorized to add additional logos here from other organizations, but we are working for ministries of defense in Europe, mainly in Europe. In the field of energy, we work with mainly with Fusion for Energy and ITER, both are fusion projects. Then also Electricité de France or Repsol, the Spanish oil company. In the field of automotive, we have Renault as our main reference, but also some other customers in Japan and now in the US, whose name or logos I cannot show you here, but we have customers in Detroit, and we have customers in Japan as well. Then the more you go down, let's say the less systems engineering we apply here, but other customers in other industries like healthcare or public institutions like the Spanish television, RTVE, or the European Land Registry Association with a lovely project on ontology interoperability, Tirant Leblanc, which is a legal company. So the last block is mainly not fully related with the requirements and requirements quality, while the rest of the industries here are clearly related with requirements, at least in what has to do with our tools implemented in this and deployed in these companies. So after this quick presentation, let me jump into the point of speaking about poor quality requirements, starting with the bad news, let's say, the impact and the why. So this is, I guess that you all know this CAUS report. This is a regular survey on the quality of projects all over the world. According to this report, this chart is rather old. It is from 2009, and this is highlighting that less than 1/3 of the projects that were started were actually ended as succeeded project. A succeeded project, according to this survey, is the one that is ending on time, on budget, and meeting all the expected scope. And only 1/3 of these projects are actually meeting the three at the same time. So the question is why? Why it is only this limited number, less than 1/3? And the second question behind as well is if I could show you the chart from the more recent years, the bad news is that this situation, these figures are not improving at all. So they remain kind of the same. So if we take the details of this survey and we analyze or we question ourselves about why, then we can find that out of these 10 factors for the success of our projects, most of them, or at least half of this number, are actually related to requirements. Could be user involvement, or it could be a clear statement of the requirement, which is having a nice stake in this table. So this will be our topic, aiming to have clear statements, and I will show you some tricks and tools to come out with clear, correct, consistent, and complete requirement specification. Right. So this will be the topic of the day, and the reason and the impact is clear. So this chart is coming from Inkosi, from the Systems Engineering Handbook, telling us how the cost of fixing an issue that is committed at the beginning of the project, but it's not found until the later stages of the project, could be from 500 to 1,000 times more expensive than detecting and actually fixing this issue in the earlier stage, right? So this is probably a well-known chart. I also like to mention these figures on the top, because they are highlighting that even in the earlier stage of the project, probably we have only consumed 8% of the overall budget of the project. However, due to the number of decisions we are taking at this earlier stage of the project, we are committing up to 70% of the overall budget. So it is important to be clear, to make clear that this 70% of the total budget that we are committing by the requirements that we are writing are actually written in the proper way, right? This other chart is also showing critical information, like the one that you all probably know. 70% of the overall number of defects that are introduced during the life cycle of the project are actually introduced during the requirements phase. However, what is even worse is that only 4% of these defects are actually detected in this earlier stage of the project. Most of them are not detected and fixed until the testing phase, what is making, if we follow the previous chart, is making our project far more expensive than the clear cost that it should have, right? So the approach of teaching our customers how to write requirements and offering them tools to actually help them write better requirements is, first of all, to reduce this 70% of defect rate to a level that is something manageable, let's say, something that we can deal with. Normally, because we are all humans and we make mistakes, so it is not, we cannot think of reducing this value to zero, but at least we can reduce significantly. The second point could be as well, if we don't reduce to zero, but we provide tools to actually have early detection of the issues or errors that we commit at the beginning of the project. Then if we can meet in a point in between this 70 and this 4%, then of course the extra cost for non-quality in our projects will be clearly reduced significantly. Because the impact of this poor quality in our requirements and lately in our projects could be huge, depending on in which industry you are related to. It could be just losing money, or it could be time to market. But remember that in some other industries, failure in the requirements could end up in failures in the systems. And these systems are the systems that we can drive, or we can fly, or we can communicate with. So it could be resulting in a harmful situation for the human being, not only time and money, but also human lives or the health of people, right? So this is why it is so important to start our projects with, as we say in Spanish, with the right foot, starting with nice requirements. Of course, nothing prevents a requirement, a project that started with good requirements. Nothing prevents this project to go wrong somewhere and to end up in a failure system at the end. However, if we start clearly with poor requirements, the chances to have a poor final project or final system are huge, right? So let's try to improve the quality of our requirements, and these are two clear examples of failed projects due to requirements. I prepared for the first time this presentation for a railway customer. So we decided to highlight two projects in this industry. It was a French customer, so we decided to have a French example and a Spanish example, both. So the first one, I don't know if you know this one, is from French Society for Railway. They were acquiring some trains that they didn't fit into some of the stations. And the overall cost of this project was huge. In the case of the second example, was a Spanish consortium, or a consortium led by a Spanish company, building the Mecca Medina railway, not considering environmental requirements like the high temperature or the sand in the railway, as you can see in this picture, right? So these are two clear examples of failed projects due to requirements. More about the impact, the economical impact of requirements. I don't know if you know about Cosismo. Cosismo is a kind of a derivation of the classical COCOMO for cost estimation in projects. But this Cosismo is unlike COCOMO. This one is more focused on systems engineering project. I don't have time, of course, to explain in detail what is Cosismo about, but it is made up of cost estimation, starting with some size drivers and effort multipliers. What is shown here in this screenshot is that out of all the different effort multiplier that Cosismo is considering, the one with a higher impact is the requirements understanding, right? So meaning that if the requirements understanding is low in a project, the cost, the final cost of this project will be multiplied at least by 3 times, right? So let's try to these are some other figures related to this Cosismo approach and how deployment of our systems engineering suite based on Cosismo estimations is making a clear benefit in the projects. I cannot go through all this mathematical study behind, but there was a webinar a couple of months ago performed by one of my colleagues at the reuse company, explaining in 1 hour all this Cosismo approach and how requirements quality or improving the quality of the requirements is clearly impacting on the overall quality of your projects, and mainly following Cosismo, mainly in the final cost of the projects. Then a couple of definitions just to highlight how both Inkosi in its Systems Engineering Handbook and also NASA in its Systems Engineering Handbook, they are both highlighting the importance of requirements from the very beginning. So this is the definition of the concept of systems engineering according to Inkosi, the International Council on Systems Engineering. And it is this definition is describing systems engineering like the interdisciplinary approach and means to enable the realization of successful systems. Of course, this is the topic of today's session, focusing on defining customer needs and requirements and functionality early in the development phase. So it is important that these requirements and these needs could be identified early in the project, and of course could be represented in the proper way, providing these understable requirements and needs and documents, right? So let me show you some ideas as well. As I said, I wanted to start with some definitions. The second is the definition of what a requirement is, and using this classical definition from the 29148 from the ISO, defining a requirement like the statement which translates or expresses a need and its associated constraint and conditions. This information is a capability or functionality, a physical characteristic, or a quality characteristics of the system or a system component, right? So this is just to be all of us on the same page with the definition of what a requirement is. Then I will try to focus part of my presentation on Inkosi and this document. This is not the Inkosi Systems Engineering Handbook. It is the Inkosi Guide for Writing Requirements. And this Guide for Writing Requirements is defining a requirement or a requirement statement like the result of a formal transformation from one or more needs or parent requirements into an agreed-to obligation for an entity to perform some function or possess some quality, right? So this definition is similar to the previous one. and allows all of us to be, as I said, on the same page. So textual form of needs and requirements are not only useful, they are mainly necessary. So we are living in a model-based world. Everything seems to be model-based. However, we still have to rely on textual requirements, and even this model-based approach is based on the definition of textual requirements as well, mainly because operational scenarios, use cases, diagrams, prototypes, tables, and other types of models are useful and necessary. And among all of these, including also textual requirements, we can, in a natural way and in a consistent and non-ambiguous way, represent the needs of a system, right? So now the definition of what a requirement is based on the NASA Systems Engineering Handbook. I like this definition because it is the first one that in the definition itself of what a requirement is clearly defining the quality characteristics of the requirements themselves in an explicit way, right? So acceptable form for a requirement statement is individually clear, correct, feasible to obtain, non-ambiguous in meaning, and can be validated at the level of the system structure at which it is stated, right? So this idea of the level of the structure is also important in the definition, and this is why also in the definition of the technical process of the requirements management, the handbook is describing the process of requirements definition like an recursive and iterative process that develops the stakeholders' requirements, product requirements, and low-level product components requirements. This is representing this the composition structure for the systems that I was mentioning before. So this figure is taken from the Inkosi Systems Engineering Handbook, and it is representing this the composition schema for a system, starting with a system on the top, which is represented by a number of different subsystems, and in turn, the subsystem can be further decomposed in lower level of detail subsystems and elements and parts. So depending on the methodology you follow, the name of these small boxes could be different. But in all of them, as you go down, you will be increasing the level of detail, and as you go up, you will increase the managerial aspects, right? But what is clear is that this decomposition makes all these related activities iterative and recursive, as I was mentioning before, and also it is describing something that has to be considered for the completeness of our requirement specifications, like the interface requirements. So this decomposition is enabling the definition of interfaces between the different components and parts conforming the system. More ideas to establish before we continue is the definition of depending on as I said before, depending on the methodology or depending on the handbook that you follow, you can call it different types of requirements, or you can call it different objects related to requirements. But the idea is that we clearly have to distinguish between functional requirements, what the system shall do, performance requirements, how well this has to be done, and other constraints, which are under which limits we have to perform this activity. So the example is this one: the cabin radio shall communicate with the central station. This is a functional requirement. The performance part of this requirement is something like the exchange rate, the data rate of 2.8 megabits per second, while the constraint is in which frequency this communication has to be established. In this example is between 250 to 300 megahertz in the spectrum, right? So important that we have different types of objects whose quality can be analyzed by means of quality rules or quality metrics in an automatic tool. We have, by the way, as well, as I was mentioning here, different levels of abstraction. And what has to be clear is that requirements of or objects of different types and the requirements at different levels of abstraction has to be measured. The quality has to be measured probably in a different way. For instance, the level of ambiguity that you can allow for, let's say, for a business requirement is not the same as you might allow for a requirement in a technical specification, a low-level technical specification, where the room for ambiguity has to be 0, while in a high-level requirement, there could be some room for ambiguity, right? Then, once we have covered these basic principles or basic definitions, the main block is on a definition of quality rules to write requirements. I don't know if you have any questions so far before I start. So I give you 1 minute to write down your questions. Are you still there? Are you alive? Good. So any questions so far? Okay, so let's continue then with this block defining quality rules to write requirements. So let me start with a distinction between rules and characteristics, quality characteristics and quality rules for requirements, right? So if we speak about quality characteristics for requirements, most of you will think of the IEEE 830 with these classical quality characteristics for requirements like correctness, ambiguity, completeness, consistency, and so on and so forth. So these are typical ones that are repeated over and over in other standards and in all the documentation, like, for instance, the ISO 29148 or the ECSS. This ECSS is defining a set of standards for the European space industry. But clearly, we are also living in a smart world, I hope, where everything is smart. So smart devices, smart cell phones, smart cars, smart cities, everything is smart. And when I think of a smart requirement or goals, I always think of this statement by Kennedy. I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to Earth. So clearly, this statement is specific. It was measurable, so we can now measure that a man has been landing in the moon. We have lasers and sensors just to know that the moon is moving away from us. It was aligned with the strategy of a country. Even if we think of conspiracy theory, the benefit was clear. They defeated some other countries in the world by that time, so it was the goal was fulfilled. It was relevant and it was limited in time. So to me, this is a clear example of what or how smart can be a goal or a requirement. However, when I think of the quality characteristics that are included in the 830 and the same for the other standards, I don't feel that all these quality characteristics are smart enough. Probably they are pretty much relevant and aligned with the strategy of improving the quality of your requirements. However, clearly, if you have ever checked these standards and you have checked for what is the meaning of correctness or what is the meaning of ambiguity according to this standard, you will quickly find that these definitions are very far from being specific and, of course, very far from being measurable. So this is the definition of what ambiguity is or what uniqueness is according to the ECSS EST 1006C. This is the standard from the European space industry, defining the requirements engineering process and the quality characteristics of requirements. So if someone wants to learn more about how to write quality requirements by using this standard, and they just see this document, of course, they will learn clearly nothing from this document, right? And this is the bad news, and this is what you can find in most of the standards and guides that you find for writing requirements. So clearly, if you want to achieve this smartness in our requirements, clearly we need something else. This something else is needed clearly because we are living in an ambiguous, or we are writing requirements using natural language. As I mentioned before, this natural language is a must for all of us in all of our projects, even if we, of course, we have to mention the idea of models and so on. But at the end of the day, we need textual statements in our projects. And natural language is prone to be ambiguous, right? So I don't know if you have ever suffered like my colleague. He's an engineer, and his wife told him to put the pie in the oven at 120 degrees. As an engineer, he took all this stuff and he prepared the pie at the oven. But I don't know if his wife is happy with the dinner tonight. And it is not only when you mix different disciplines like cooking and engineering when you can find difficulties and ambiguities in the communication. It is also even within the same discipline where you can find ambiguity and misunderstanding in your communication. So, for instance, this team of people, these three guys are engineers, while she is speaking about pie, like, okay, meaning pie, she said. Then this guy is, okay, pie, oh, this is pie, oh, nice, easy peasy, so this is pie. This is a more formal guy, more strict guy. Wow, no, pie is not that. Pie is all this is pie. So misunderstanding everywhere. And even my colleague, the last one in the team, thinking about pie. Oh, pie. What is pie? Oh, pie. Yes, last night pie. Right. So let's try to overcome this issue of ambiguity and the rest of issues with our requirements. As I mentioned before, and I will be mentioning several times, our approach in parallel with Inkosi and the Inkosi guide for writing requirements. For those of you who don't know this guide, this is a free document for Inkosi members, and this is describing characteristics of requirements on the top. But the good news is that together with this very high level and very good to have, but very abstract and not measurable set of quality rules, this guide is also defining a number of different, I said quality rules, I was meaning quality characteristics. At the very high level, what we find are characteristics, as I said, all of them nice to have, but very abstract and difficult to be measured. And the good news is that after the definition of these, all these quality characteristics, they follow with the definition of a number of quality rules. These quality rules are transforming the quality characteristics in something that can be measured both by humans and also by tools. And the 14 quality characteristics, 9 for the quality of individual requirements and 5 for the quality of sets of requirements, is transformed into 41 quality rules. As I said, provided that unlike the quality characteristics, now the quality rules are easy to be measured. Together with all these characteristics and rules, Inkosi is defining a number of up to 46 attributes, optional attributes for requirements, right? So if you can reach this Inkosi guide for writing requirements and you want to learn more about requirements quality, I encourage you to proceed and download this guide, right? In our approach, the approach that I will be also showing you in the second part of this session, I will show you a set of tools where we have taken all these quality rules from the Inkosi guide, together with a bunch of other rules that we have identified ourselves by our own experience or our experience with our customers. We have put all these together, and we have ended up in such a large number of what we call quality metrics that we had to classify into 3 main blocks. So in our approach, we classify metrics in these blocks. Correctness is or are all those rules to check the quality of individual requirements, while completeness and consistency are more focused on sets of requirements or even sets of requirements documents, right? As I said, all of this is based on the Inkosi guide for writing requirements. However, my recommendation always is not to take all these rules, all these 41 rules in the Inkosi guide and apply these rules from the very beginning. Mostly because if I ask all of you to have all your requirements starting tomorrow, following these 41 rules, probably you will kick me out of your office and will tell me, okay, I don't rely on this guy and I don't rely on the Inkosi guide anymore. So the idea is to establish a sequence of different steps that can allow you the successful implementation of these quality rules, not as a single step. Okay, from tomorrow on, I want you to follow all these 41 rules. However, our approach is more a steady approach with different smaller steps that are easy to be taken one after the other towards the final goal, right? So if you want to learn more about this process, we have released a book on how to tailor the rules in the Inkosi guide for writing requirements. So this book is based on tailoring process on top of the tools that I will be demoing you in the second part of this session today, right? So let's start with a number of rules that we always like to improve in our customers. In our approach, we have defined 15 rules. It is not as large as the Inkosi guide with these 41 rules. It is 15 rules. But of course, we can transform these 15 rules into a larger number of metrics in the tool, as I will show you in the second part of the session today. So first one, to me, this is clear. Keep your requirements short and precise. Of course, not too short. A one-word requirement is not a good requirement, but of course, a half-a-page requirement is clearly too much as to be considered as a single requirement, atomic requirement, right? So only one single action per requirement, consistency in the length of your requirements, and avoiding narrative paragraphs. Avoid verbose or bombastic expressions like shall be designed to. So why speaking about shall be designed to instead of just simply saying the system shall do something, right? So here you can find a couple of nice examples as we experienced in our last 5 projects, and due to the change in the regulation, the system shall do something. Clearly, this is you are telling almost nothing. So the only main part is the system shall do something. So why not having something more concise, like the system shall connect to at least 4 satellites in less than 5 seconds? So this is a valid requirement, which is by far shorter than the previous one. Or something like under no circumstances the system shall perform X, whatever action, instead of just saying the system shall not perform X action. So this is shorter and more concise, right? This is a nice study that I found on the length and other characteristics of requirements, but it is telling us that while the average sentence in English for other domains, not requirements, let's say legal documents or the news or whatever, the average length of a sentence is 18 words. For a requirement, as an average, it is 25 words, right? So clearly, it is larger a requirement than a regular statement in a book or in a novel, in the news, right? It is a little bit larger, but it doesn't have to be 50 words or half a page requirement, right? So try to keep this in mind and be more concise, removing needless information. The system shall be capable of. Why not? The system shall do something. Normally, because long requirements include additional details like the use of attributes of the requirements within the body of the requirement itself. Sometimes in these long statements, we are providing the solution. Of course, we have to avoid the solution in the requirements or providing different levels of information in the same requirement. It's better to use other documents to provide those details and to keep the requirements consistent with the level of abstraction of the different documents. Remember that normally if you will find more than one requirements document, you don't have to write everything in one single requirement. Of course, requirements with the conjunctions like and or also, please avoid this, right? Because this is making larger requirements and mainly non-atomic requirements. When you deal with non-atomic requirements, then traceability is jeopardized clearly, and verification of these large and non-atomic requirements is a nightmare. So please avoid large requirements, right? So here you have more additional information on this, right? Avoid the use of parentheses. Normally, parentheses are providing additional details that probably should be put away in a different attribute, right, or a different section of the document. So rationale, avoid rationale in your requirements. The rationale has to be an additional attribute, and rationale or assumptions, they don't have to be in the main body of your requirements, right? So once you have short and concise requirements, why not agreeing on the modal verbs to be used? In my personal case, I always like to write requirements using shall and only shall. But of course, there are other approaches where you can mix shall, should, or shall, will, must, whatever, right? So it doesn't matter. In fact, we even have a customer who decided to write with something like shall, should one, should two, and should three. So this was the four modal verbs, if I can call should three or should one a modal verb, but they decided to write in this way. The good news is that for all of the members in this team and this company, it was fully clear what was the difference and the distinction between shall and should, and the distinction between should one, should two, and should three, right? So provided that you agree on what should be the modal verbs to be used, then please stick to these modal verbs and use these modal verbs in a consistent way, right? And normally, as long as you can, after the modal verb, a main verb, and not a name of the action, which is called in some bibliography, it is called nominalization. So please avoid the nominalization. After the shall, a main verb, the main action of the requirement, right? And as I said, of course, no problem if you want to use will or should for other elements that are not requirements, like will for requirements that do not require a verification process, or will for non-mandatory requirements, or will for facts, and should for goals, and shall for real requirements. So please agree on one schema to be followed and be consistent to this schema. In my personal case, always shall, but of course, as I said, please do as you wish. And of course, it is not only to agree on the use of shall, should, will. It is to, as much as possible, to have only one main action, only one shall per requirement. It is not only to count a number of shalls, it is also to count the number of actions after the shall. Because if I write something like the system shall evaluate and report information from whatever, then clearly, even if these two activities, evaluation and reporting of the result of the evaluation, are two actions that somehow can be or are actually related. However, traceability, impact analysis, and mainly verification of the requirements will be hard if you don't manage to split this statement into two verifiable requirements, right? So please try to have not only one shall, but mainly one single action per requirement. Rule number 4, sorry, is the use of passive voice. Active voice is always better than passive voice in requirements, mainly because passive voice is prone to missing the subject, and to me is something that has to be clear together with the main action described by the requirement is the definition of who is the entity in charge of performing this action, right? So clearly, passive voice, even if we can have other elements in the sentence, but normally passive voice is prone to missing the subject, so please don't use passive voice in your requirements. However, what is important to mention is that if you use a text analysis tool to analyze the content of your requirement, so for instance, in this one, you can find something like the passive voice here when the car is stopped or when reverse gear is engaged. So this is technically speaking or linguistically speaking, this is passive voice. However, passive voice in the condition of a requirement normally is not harmful. Our system has to perform this main action to start the motor when this condition is met, no matter how this starting condition is met, right? So we don't need a clear agent in the condition. However, we do need a clear agent for the main action of your requirement, right? So having said that, while passive voice in here is not harmful, passive voice in the main action, it can be harmful, right? So the user shall be informed about low level of fuel. We are missing which element in my system is in charge of informing the user about low level of fuel, right? So this second statement here is clearly missing the agent. But there are other ways to miss the agent, and not only with passive voice. So, for instance, this sentence is not using passive voice, but the structure "there shall be something" is clearly again avoiding or minimizing the focus on the agent in charge of this requirement, right? So to me, this is not passive voice. This is passive voice, but to me, clearly both are equally poorly written. This is why I have renamed this avoid passive voice that you can find in every book or guide on how to write requirements. You always find the avoid passive voice, but I prefer something like please mind the subject or the agent which is in charge of performing the action of your requirement, right? More than passive voice, right? So this is not passive voice, and it is equally a bad requirements to me. And remember the idea of what if the passive voice is on the condition. To me, it is not an issue when the passive voice is in the condition, right? So rule number 5 is avoid vague adjectives and adverbs. So adjectives or adverbs like user-friendly, rapidly. At the end of the day, if you remember the quality characteristics that I was mentioning 10 minutes ago, the idea behind every requirement is that it can be understood in one single way in order this requirement to be implemented, and understood in one single way so that this requirement can be also verified, right? If you use things like user-friendly or rapidly, probably your concept of how fast something is as to be called rapid is different from the one that I have, right? And it could be different from the customer to the guy writing the requirement specification, to the guy implementing this requirement, and also to the guy verifying the system against the requirement, right? So please avoid this kind of vague adjectives and vague adverbs in your requirement. Provide exact values for things like rapid. So rapidly, how rapid is rapidly, or what temperature is hot. If you speak about hot, what is the temperature that you consider hot? So this is the kind of things that you have to clarify in your requirements. Sometimes what in one industry could be or in one domain could be ambiguous, in another domain could be non-ambiguous. So for instance, the name of a color could be ambiguous for someone. So something like red could be nice in some domains or not. If you say red, what do you mean? Do you mean dark red, light red? Why not providing an RGB code for this red or other standards for without any doubt representing a color, right? Of course, some other adverbs like quantifies, approximately, or to represent ideas like usually or nearly. So this is always to be avoided. And these are two examples of requirements to be avoided. When the water temperature is close to boiling, so how close is close to boiling, the air conditioning shall, or the need of training for the end users shall to be close to zero. Again, is the use of close. So what do you mean by close to zero? So rule number 6, use vocabulary consistently. As I was mentioning in the introduction to this session, our approach is a knowledge-centric approach. So for us, in our tools, knowledge-centric knowledge is the central point of the systems. This is why we always deal with dictionaries, control vocabularies, glossaries, taxonomies, thesaurus, ontologies. So this is something that comes behind of our tools. We try to hide these concepts as much as we can. Normally our customers, engineers writing requirements, they don't want to deal with the definition of elements in an ontology. So we manage most of the times to hide these concepts, even if the concepts are there, providing the benefit for the end users, as you will see during the practical part of the meeting, right? So why not starting with control vocabulary? In most of the requirements documents that you write, probably you will start with the definition of acronyms and the definition of some key concepts in your document. However, at least in a lot of documents that I have been or documents that I have found in my career, I have found requirements where the section of acronyms or the section of definitions is just kind of okay. I'm asked to have this section here, so I put the section. I include a couple of items, but no more. 2 items are enough. This is what I found normally. So in our approach, we encourage our users to explicitly define a large list of elements so that each of these elements might have a clear definition of what is the meaning of this element, especially if the meaning of the element could be different or could be slightly different from the classical definition of this element that you might find in a classical, let's say, Oxford dictionary or whatever other English dictionary, right? So please start with the definition of these elements and use these elements in a consistent way, right? So if you define the name for one particular element, please use this name consistently across the document. Avoid repeating over and over in your requirement something like when you use a particular name, open parentheses and provide the description of the name. No. A requirement is not a dictionary. So please use dictionaries outside of the text of the requirements, right? And as I said, clarify every of the key elements in this dictionary, right? An example could be something like when the vehicle is stopped, the engine shall be cooled, and at the same time the AC system must switch to B mode. So in here it is an example of when in the same requirement you are mixing up a large number of elements from a dictionary. Normally this is not a good approach as well. So having full list of the agreed names in your domain is another good way of controlling the length of the requirement, because you will be focusing on one single element and one single action. So as as you are capable of defining these actions and elements in your dictionary, normally it helps you focus on individual targets in your requirements and not mixing up different number of elements. And the good news of using an automatic tool is that we can easily detect when the number of key elements in a requirement is more than a number that you can define as the limit, right? So use always the name of your dictionary. Don't abuse of different of these elements in the same requirement, and use all these names in a consistent way, right? Rule number 7 is a kind of subtype of the previous one. Is more specific for acronyms. So while it is important to define in a dictionary all the key elements in your business domain, it is even more important to define acronyms. Every single acronym that you find in your documents has to be clearly identified in a dictionary with the clear meaning of all these. If I ask you for what is the meaning of all of these different acronyms, so probably you will agree on some of them, but for some others it could happen that SMS probably we can all think of texting people with a cellular phone. However, in some other disciplines, SMS could be the acronym for something else, right? So in order to clarify that, create a dictionary including acronyms, and do never use an acronym in your requirement which is not explicitly identified as an individual entry of this dictionary, right? Something else to be avoided is similarly to what I was mentioning before, the idea of using the requirement like a dictionary, including something like the requirements quality analyzer, parentheses RQA, close parentheses, shall, blah, 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 whatever. So please take the full name and the short acronym name in a different document in the dictionary, and keep your requirement short and concise. So you can choose using the RQA shall or the requirements quality analyzer shall, but avoid things like this, right? Okay. Rule number 8 is please don't be afraid of repeating the same elements in different requirements, right? So I still remember my Spanish teacher many years ago when she was teaching me how to write properly. Of course, she was not aiming to write requirements. She was more close to write other types of literature, not requirements. With the idea of, okay, Jose, please try not to repeat the same concept over and over. Use a synonym, use other names, use pronouns. Pronoun replace the noun. So please don't or avoid repeating over and over. Use these pronouns or use whatever, right? However, some years after this Spanish lesson, I discovered requirements, and then I found, okay, no. Requirement, we must repeat mainly the subject. So why not having a requirements document where, I don't know, 50 statements are starting with the same subject, always the same. The car shall, or the whatever, the antenna shall. So why not having the antenna shall as the subject for 20 pages of your document? You don't have to be afraid of this, right? So you are not going back to school. So please lose the fear to repeat the same concept over and over. And what is more, please do not use pronouns in replacing the noun. So this is what you have been taught at school. Use pronouns. So please avoid the use of pronouns to refer to a given name. Mainly because most of the time the pronoun is referring a statement that probably in your document or in your tool could be just the statement in front of the current one that you are writing. However, in a regular database or requirements management tool, As you know, you can sort requirements by different criteria. You can filter requirements. So what today could be requirement 1 and requirement 2, and in requirement 2 I could be using a pronoun, thinking that this pronoun is meaning the main concept of the previous requirement. When I filter my requirement set, probably the requirement that is now in front of the one that I am reading is not the same than that I had yesterday or a week ago, and probably I could be meaning or understanding something very different from the actual intention of this requirement. So please avoid the use of requirements, and please don't be afraid of repeating over and over and over and over the same structures in your requirements. Remember that a requirements document is not something that you will take when you go to bed and okay, I want to read something interesting. Nope, normally it is not going to be a requirement document, so it is not an issue if the requirement document is a boring document. So don't be afraid of writing boring documents, but make these documents unambiguous. Make that everyone involved in this requirements document understand exactly the same when they read the same, right? So don't use pronouns. And if you are meaning, for instance, in this requirement, if you are meaning doors and gate and doors is the same, don't use doors here and gate here. If this is the same element, use doors and doors or gate and gate, and do not mix synonyms or closely related concepts in your requirement. If you are meaning one particular element in your dictionary, so go back to rule number 6. If you are meaning something specific from your dictionary, use this name over and over and over, even if it is a boring document repeating the subject over and over, right? Okay, so requirement or rule number, this is rule number 8, 9, there is a mistake here. This is rule number 9. Keep the level of detail in mind. Remember what I was mentioning when I was describing the system at the high level, but also the logical architecture of this system, the composition of this system, right? So when you write requirements for the full system, the entire system, you should be thinking of this document like if the system is a black box. If you don't know the details, the implementation details of this element, right? So just to avoid advancing in the details while you are still writing the needs of the high level document, right? So please keep this in mind. And normally in your documents, as I said, if you write a requirement document for the full system, let's say a car, if you write the requirement for a car, but also you write after that the requirements, you make the decomposition of the car into a number of different systems and then subsystems and so on and so forth. Then when you are addressing system A, please take the system A like a black box before the decomposition. So normally all the requirements or most of the requirements in this document will start with the system A shall and not the subsystem A.1 shall, right? So keep the level of the abstraction and the level of detail in mind. Then requirement number or rule number 10 is be aware of negative requirements. So if you go through the definition of different quality rules in the literature, in the Inkosi guide or NASA guide or other sources of quality rules, you will find the idea of do not use negative requirements. Of course, negative requirements are normally or could be misunderstood in some circumstances. So it is always better if you can rephrase your requirement as a positive statement. It is always better to use a positive statement. Of course, this idea cannot be achieved in every single requirement, especially if we deal with safety requirement. It is difficult for most of the safety requirements to be written in a positive as a positive statement. So something that you can do with the help of a tool is, for instance, to implement a metric in a tool to detect negative requirements, but not for every single requirement, but also for only for the requirement, for those requirements that are not safety requirements, right? Of course, do never use more than one negative clause, more than one negative particle, in the requirement. So requirement or any statement with two or more negative particles, you will never know if this is if two negative is a positive or not. So please either don't use any negative block at all, or use only one, and if possible, only in safety requirements. Also, what is important to mention is that it is not as simple in practice as the detection of a not a particle. In some cases, you will find a not as part of a condition. A condition or the trigger for a given requirement can be a complex condition, and this complex condition might have the negative not, the logical not, let's say, in the expression of the condition, right? So this not, of course, is not considered when I say do not use negative words like not, for instance, right? So I am not considering that a not in the condition is an issue. In fact, it is not an issue. It's just representing a complex condition, right? And these are just two examples that along all the flights that I have had, not this year, unfortunately, different statements that I find very difficult to be expressed in a positive way. In fact, as I was mentioning, this could be a kind of a safety requirement, so it doesn't have to be written in a positive way, right? So I don't know, it is very little font here, but do not open door if red warning light is flashing, cabin pressurized, right? If you think of, okay, how can I write this in a positive, as a positive statement, while the negation is only if red warning light is flashing. So I don't know if you can do it, but to me, I find it very difficult. So why not keeping this negative as a kind of requirement, provided that this is mostly related with safety, right, and not functional, pure functional requirement, right? In here there are some other examples. I think I don't have time to cover these today, right? So rule number 11 is solution-free requirements. Don't state the solution. So in most of the cases, or in some cases, when we are promoted as okay, you will be the business analyst or you will be the requirements analyst, is because we have been fighting in the war for so many years that we know the details and we think we know all the possible implementation strategies, right? And we as human, when we are asked to provide the details for something in a requirement, we tend to provide not only the need but also the solution, of course, because we are very good in that. So we try to provide the solution. So please try to keep your requirements a solution-free statement. Do never focus on the how, focus on the what. And this what and how always makes me think of my typical question when I write a requirement, which is not how, of course, but it is not what. It is normally why. So if you are asked or if you think of a requirement like the system must implement a relational database, why relational database? So probably probably it is because I need the system to have unique identifiers, or I need the systems to be linked together, or I need the items, or I need the items to whatever. Then if probably these are the actual needs of my systems, to identify elements in a unique way, to link elements together, or to do whatever. So if this is the case, the real requirements has to be these ones, and never just the requirement of implement it as a relational database just because I know that a relational database could be a very good solution for this problem. So keep the problem away. Just focus on the what, but always ask you the why after each requirement, right? So Atomicity. This is another good point when it comes to the quality of requirements. While, as I mentioned before, while atomic requirements will make your requirement specification easier to be traceable and easier to be verifiable, sometimes non-atomic in terms of tables or continuances, this way of writing using bullets, as for instance as this one here, an example of a requirement with 2 bullets here. Sometimes this approach is a very good approach for consistency and completeness. Of course, not for verifiability or not for atomicity and not for traceability, but it is a good topic for completeness, because you have all the different options all together, right, in the same requirement, in the same statement, and it is very easy to add one more or to remove one more in this collection of bullet points, right? So sometimes you have to ask yourself and balance yourself if you want to promote more atomicity or if you want to use more kind of tables of continuances, right? In my approach, the answer is clear. Atomic is always the best choice, but I have to admit that sometimes there is a trade-off, and what could be good for the atomicity could be not that good for having an easy checking of the completeness of the requirements, right? So please make this trade-off for yourself. However, in any case, when you write using this kind of structures, please consider always things like the system shall do whatever when condition A and condition B. This when column and then a list of bullet points sometimes can make you ask yourself, okay, do you mean that these 2 conditions has to be met at the same time in order this requirement to be triggered somehow, or this is a kind of or statement, condition A or condition B is met, right? So please avoid this way of writing, and why not replacing this just simple when column by something like when one or more of the following condition, this is an or when all of the following condition, this is an and in your statement, right? So rule number 13, we are approaching the end of my 15 rules, is avoiding other or identify other terms that has to be avoided. It is not only ambiguous adjectives and adverbs, as I was mentioning before, but also actions can be ambiguous. It is probably for some of you it was not so strange to find the idea of avoiding ambiguous adjectives, but as I said, actions can also be ambiguous. So if you are launching something into the space and you find something like the proof or the system shall survive, whatever. So what do you mean by survive? Survive is that it is not decomposing atoms, or survive is that it keeps the shape. Survive is that it keeps working as expected. What do you mean by expected? So please avoid actions that are vague and difficult to be measured and to be verified, like survive or to manage. The system has the requirements management tool shall manage requirements. Oh, what do you mean by manage? Manage is meaning just storing. It's meaning storing plus linking. It is meaning having attributes. What do you mean by manage? So please avoid these kind of actions as well. Imprecise quantifiers, several, many, close to 0, as I was mentioning before, few, sufficient, lots. So please avoid this. Avoid also escape clauses, if possible, if necessary, as required. No. Something has to be done or not, but it is not if possible or if necessary. Open-ended, also to be avoided, etc., and so on. Please avoid these ones. Don't speculate. If possible, as appropriate. This is partially this kind of escape clauses. Absolutes. I never like to use absolutes, not only in requirements, but also in human life. Something like all, never, always, everybody, nobody. So it is normally difficult to control when you say all signals or under all inputs. So what do you mean by all inputs? Probably the inputs that I know today are not the inputs that the system can find tomorrow, let's say. So when you say under all inputs, blah, 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 whatever, probably this is not clearly a good requirement. Superlatives, the best, most, something like this. Comparatives, better than or higher quality, whatever. Or unbound concepts, not limited as a minimum. So please avoid, prepare a list of including all these expressions, and please avoid these expressions in your requirements. Numbers. Wow, it seems that when we write something, we always think of words, but numbers are normally part of our requirements, especially for systems, physical systems. We have to deal with environmental variables. We have to deal with a lot of different topics related with numbers. So, especially in multinational projects, agree on the format of the decimal number. If your decimal number having two decimal, a comma to represent the decimal, and then a dot to represent the thousands, let's say, and the millions, or it is going to be a comma for the millions and thousands and a decimal point in front of the decimal part of the number. So please agree on what should be the format for numbers and be consistent with this, right? Also, when you write numbers between, let's say, between less than 1 or let's say between -1 to 1, let's say, a number less than 0, positive or negative, please do never forget the 0 in front, right? So do not write something like 0.99 or 0.99. So this is normally not acceptable in requirements. Or in any other document, please use 0 point or 0 comma to represent this, right? Also, it is not only numbers, it is also units. Please do never use a number which is not followed by a measurement unit or followed by an entity. So when the speed reaches 120 miles per hour, this is a good requirement. Shall connect to at least 4 satellites. This is a good requirement in less than 10 seconds, right? So think of other ways of writing numbers that are not numbers to qualify an entity or to qualify a number, to quantify a number of units, right? So please avoid the numbers that appears just on their own in the sentence, right? Also, speaking about units, agree on the units to be used. If you want to use miles per hour, agree if you want to use the acronym or the full text, agree on in which way. And similarly, agree on what is the measurement system that you want to apply. Do you want to use the international system or metric system or imperial system? So which one do you want to apply? Also, think that in some industries or some companies, this is a real example that I found in one of my international automotive customer. When I was speaking about this rule of using one specific measurement system, they told me, oh, this is not possible in here, because our way of speaking about the speed, it was a multinational company, European part American. They told me, no, we are obliged to write something like this. When the speed of the car is below 5 miles per hour, open parentheses, 8 kilometers per hour. Then, of course, if your guideline on how to write requirements in this specific company is asking you to write in this way, of course, you cannot apply this rule, or at least you cannot apply this rule to speak about speed. You can apply the rule to speak about other elements that are not speed. And what is important is that if you are asked to write it this way, please be consistent and always write in this way. Don't write the following requirement first in kilometers per hour and then in miles per hour. If this is the format, please stick to the format that you have agreed. More about units. Use units consistently for the same magnitude and for the same system element or parameter, right? So what do I mean? What I mean is that even if liters and cubic centimeters are both part of the metric system, but if I speak about, let's say, for instance, the capacity of the fuel tank, do not speak one requirement is using liters, one other requirement using cubic centimeters, other requirement using cubic deciliters, and so on and so forth. Because at the end of the day, you will find someone having a quick read of your requirement and probably misunderstanding the idea. If I decide that the capacity of the fuel tank has to be given in liters, use liters. Even if it is a small liter, use 0.01 liter or whatever. Do not say 1 liter in requirement 1, and in requirement 2, 1 centiliter, and in requirement 3, 1 deciliter, because probably you will miss the actual meaning. Of course, coming back to the idea of numbers, of course, a number is far better than something like some, most, few. Suppose this requirement in here telling you to connect to instead of 4 satellites, something like to connect to some or some few satellites in less than a while. Let's say no, this is not good. So always a number better than these kind of quantifiers, vague quantifiers, and of course always better than adverbs. So less than 2 seconds is by far better than rapidly. So I'll connect rapidly to some satellites or to some few satellites. This is an awful requirement, right? So a little bit more about numbers and units. In nature, in a real world, an exact value is normally difficult to find, right? So if I say when the voltage of the system is 5 volts, so normally I will never find 5 volts. I can find 5.1 or 4.9 volts, something like this. So normally some of these values has to be given with proper tolerance, right? So something like the temperature of the oil must be at least 80 Celsius plus minus 5%, right? So to me, this is a nice requirement. There could be different ways to represent tolerance. Could be using plus minus and then the other value, or plus minus and then a percentage, right? But please agree on in which way you want to represent these tolerances. Of course, when it comes to tolerance, a tolerance that is very high, very excessive. So something like this example, the format of this seems to be okay, but to me a tolerance of 60% is far too loose, too high, or too big. The tolerance compared with the nominal is in this case 60%, in this case it's 50%. So this is too much to be a requirement. So to me this is excessive. And on the contrary, something like this, 80 Celsius plus minus 0.1, this is so tight that it is almost like no tolerance at all, right? So please stick to some limits and never be too open or too tight in the tolerance. If we skip the element of tolerance, but still working with numbers like 100%, I hate 100%. I told you before that I hate the requirements using things like absolutes, always, all, every time, everyone. To me, 100% is kind of the same, right? So I don't like to find something like 100% reliable, 100% available. We know that no system in the world, or at least designed and built by a human, is 100% reliable. So please avoid 100% in your requirements. Also, you know that some verbal structures require some sort of numbers. So a requirement including the action to increase or reduce something. After this something, you must write a number, either a given number or a percentage. So in this case, when the temperature exceeds 30 Celsius, the flow of air must be increased by or in 10%, right? So this kind of verbs has to be followed by a specific amount or a specific number, right? and of course make sure that the boundaries values are clearly defined, if it is inclusive or exclusive, if it is greater than, or if it is greater than or equal, has to be clearly stated in your requirements always when you use these operators, right? Well, rule number 15 is be consistent with the structure of your requirements. For us, the notion, the idea of a pattern is something that is the key of our tool. So even if you decide not to use patterns when writing requirements with our tool, behind all the syntactic and semantic analysis, we will be using patterns, right? Mainly to identify what is the main role of the different elements in the requirements, right? So this is, for instance, a typical requirement in the 29148 in the ISO, right? When a condition happens, then an entity, an agent in my system shall perform an action on an object within a time constraint. So this is a typical requirement pattern, right? Following patterns is a means of there are many benefits behind the use of patterns. First one is they help you have complete requirements, never to miss one important element in your requirement. Second, on the contrary, they help you not to have huge requirements. Remember, rule number one: be concise in your requirement. So when you know and think of this pattern like a boilerplate or like a kind of game where you name the different elements for the different blocks, just kind of fill the gap in your requirements, then you will have a short and concise, but yet complete requirement, right? There are many other benefits in the use of patterns. So, for instance, remember when I was speaking about atomicity, I think I didn't mention. Please do never use something like and or in a requirement. So the system shall do action 1 and action 2 is not a good requirement, or elements A and B shall be like this. This and is normally telling us that something is not atomic. However, if the and is coming in the condition, similarly to what I was mentioning when I was speaking about negations and the not particle, I said when the not is part of a logical expression, a complex expression for the condition, it is of course welcome. There is no issue in having not linking together parts of a logical expression. The same happens for the and, right? So it is not an issue if the and is coming in the condition, right? It is not making your your requirement not atomic, right? So the use of patterns allows us in our tool to know that if I use an and or a not, but this and or not is coming in the condition, it is not an issue. And the same for the passive voice, as I will show you in the demo. If I use passive voice in the condition, normally, at least in my approach, normally a passive voice in the condition is not an issue, while a passive voice in the action is normally prone to missing the subject, and this is to me the clear topic, right? So these are benefits of using patterns, together with the idea of, as I said, even if you don't want to use patterns, we will be using patterns to extract, for instance, the actual value for a given property. If you write something like the power consumption of the computer shall be whatever, then this value, we can extract this value with the help of a pattern so that we can operate with this and and we can provide you with consistency metrics to tell you this power consumption is not enough as to allocate power to the rest of the elements in the system. So these kind of things can be done because thanks to patterns, we can extract this information from the requirements. And that's all. These are my 15 rules. But before we close, rule number 0, which is the most important of all my rules. These rules are not the 10 commandments. So this is not something written in stone. And as I was mentioning when I was mentioning rule number 13, when I was speaking about absolutes, never say all and never say always. So please do never try to apply all these rules in all your documents. So it is normally not the way. Please use your common sense and describe or think of the rules that are applicable for the different level of abstraction, applicable for the criticality. I didn't mention today something that we normally deal with, which is the criticality of the systems. Doesn't matter if you will be using tools like the ones I will show you in the second part of this session to have automatic quality checking, or if you do manual checking. At the end of the day, you need to devote some time to do this inspection of the document. And of course, time is a scarce resource in our projects. And normally, when our projects are running out of time, I don't know why. Don't ask me why, but there's never time for quality. We have to cut out time in quality and in inspection. But nobody thinks the idea. Okay, why not having if I am I'm running out of money? Why not thinking of why or wow? More quality will make the benefit of less rework, which is meaning cheaper project. No. Normally we think of the contrary, and we try to reduce on the quality. So since we know that we don't have all the time that we need to inspect the quality of your requirements, why not thinking of the criticality of your different components in your systems? Some components are more critical than others, so please do not apply the same strictness in the inspection of the entertainment system in a car than the element which is controlling the engine or the braking system of the car, right? So think of these kind of ideas, right? And these are my 15 rules as a summary, with rule number 0, the common sense on top of all of them, right? And just before we stop for questions, just let me give you some few additional ideas around this. So the first one is, remember, text is not the only way. As I was mentioning at the beginning, we have to deal also with models. But remember the idea of keeping your requirements consistent with your models. During the demo, in the second block of the session, I will mention this and I will demo this part. Then second one is about what I was mentioning in the previous slide. One size doesn't fit all. Please use the common sense to tailor a little bit the rules from one project to the other, or from one document to the other. Identify and manage your sources. The sources of your requirements is the source of the completeness of the systems. If you miss one important stakeholder, or if you miss one important component, of course, you will not have a complete specification. Requirements statements versus requirements expressions. This distinction, statement versus expression, is given, for instance, among some other standards, is given in the Inkosi guide for writing requirements. The statement is just the textual part, while the expression is also including additional blocks like attributes and so on. Remember the idea of do not mix up in the textual part of the requirement the need itself and the rationale, for instance. Keep this rationale as a separate attribute in your requirements management tool, right? More ideas. Remember the communication theory. If you remember this from a long time ago, there was something that I learned, that is when you have an issue in the communication, the issue is never in the channel, the issue is never in the noise, and the issue is never in the receiver. The issue is in the sender. So please bear this in mind. Write your requirements according to the, generally speaking, always write whatever you write, thinking of the level of understanding of the receiver, and never just on your own level, right? Do not reinvent the wheel. Of course, this is we are a reuse company, so reuse of requirements is also important. Field evolution. This is meaning that normally when we deploy quality rules in a tool, it is not a one-step deployment. So normally what we do is we start with a small number of rules, and increasingly we involve more and more rules until we reach the level of rules that we want to apply. Do never try to apply a kind of revolution with 15 rules from one day to the other. Start smoothly with a small number and increase the number of rules or the strictness of these rules. And my final recommendation, which is the starting point for the second block of this session, is why not a tool to help writers and inspectors having a better quality requirements. And this is exactly what I will show you in the second block of this session. So that's all for the first block. Now I will introduce you the Systems Engineering Suite and the tools Requirements Content Analyzer and Requirements Authoring tool. But before that, we can have the questions and answer section, and of course, we all deserve a break, a 15-minute break. So I hope you have followed me, but in any case, your questions are welcome. So I give you some minutes for questions. The first question is if you can have a copy of the recording. Yes, you will be given a copy of this recording. No problem. Okay, was everything clear? No questions? Okay, then we can stop for 15 minutes. Okay, so if you don't have any further question, I continue with more practical part of the session. Before I show you the tools into action, let me just introduce these tools and give some names of the different tools that you will see today. I will show you the Systems Engineering Suite, the current version that we have in the market, which is version 18.3. There are 4 main tools in this version of the tool. I will not mention today anything about traceability with our tool Traceability Studio, so I will focus on the other 3. So starting with RQA, Requirements Quality Analyzer or Quality Studio. This is the tool that we use to set up the different set of rules. So what we have done is we have packed some of these rules that I mentioned, the ones that I mentioned in this session, into a library, a knowledge library, and we have implemented these rules into metric. So when I speak about rules, I will be speaking about, let's say, a document, a guide, a checklist. When I speak about metric, it is the implementation of these rules into a tool, right? So with RQA, first you can establish what are the different set of rules. As I mentioned before, you can create a different set of rules for documents at different level of abstraction, or you can define different set of rules, one for beginners, intermediate, or advanced. For instance, in our approach, what you can find, and you will see in my demo, you will find something like white belt, yellow belt, orange belt. So something like in martial arts with or karate or this kind of stuff with different belts, and meaning different levels of skills for the users. So levels of abstractions, levels of skills. So all these can be configured in RQA with different set of rules, right? Then the second topic is that RQA is not a requirements management tool. So you cannot manage the requirements with RQA. You can analyze the quality, but you cannot manage requirements. So in fact, the requirements that you can analyze with RQA has to be managed in an external repository. It could be a kind of a more professional requirements management tool or ALM like IBM and DOORS or PTC Integrity or even Excel could be requirements repository. So that when you establish a number of different sets of requirements quality rules, then you can assign one particular set of rules to one of these documents. In the case of DOORS module or project, you can apply different set of rules to the different modules in the project. Same for Integrity Lifecycle Manager. You can apply a different set of rules to the different documents in Integrity. Even in case of Excel, you can apply different set of rules to the different sheets into the same workbook, right? And then you can go back and open RQA and analyze the quality of these documents following the rules that you have established. The idea is that RQA can connect to these repositories and many others, as you will see in a minute, and retrieve the requirements from these repositories, analyze, and then release the requirements. We will never copy or import the requirements in RQA, right? So the second tool is the authoring tool. Under the funny name of RAT, following the acronym of Rich Authoring Tool, it is a kind of, if you have watched the cartoon movie Ratatouille, where a kind of rat is helping a cook to cook better. It is kind of the same. Our RAT tool is helping engineers to write better requirements. This is the idea. So unlike the previous one, unlike RQA, the RAT tool is an add-on on top of the different tools. It is an add-on on top of IBM DOS Next Generation, PPC Integrity, Lifecycle Manager, Excel, Team Center, and some other requirements repositories, right? So as an add-on, there is no external tool. It is embedded inside the host requirements management tool, so that you can write requirements, and in real time. It is not, while RQA is a tool for the quality people, the RAT tool is more for the author, for the engineer, for the business analyst writing the requirements. So in real time, the requirements that you write will be analyzed with the set of rules that you have established for this good document in RQA, right? So both tools will be sharing the same knowledge repository. So this is our quality database. Let's call it in this way, or system knowledge repository. So since all these tools are sharing the same repository, when a particular set of rules is applied in RQA for a given document, when you open this document, let's say with DOORS, for instance, then the RAT add-on, the RAT plugin, knows that, okay, the set of rules that I have to follow is this. So these are the rules to be followed, so that when you write requirements and any of these rules is not met, then you will have a red light saying, something is wrong, something is not following the set of rules that has been defined, right? So this is the RAT tool. And then I have been mentioning, in the previous session, acronyms, control vocabularies, patterns, a number of different things that normally are not managed in our requirements management tool. So we need another tool to deal with all this. And this is our knowledge manager tool, KM. KM is the tool to deal with the dictionaries, glossaries, taxonomies, and also the definition of the patterns. Out of the box, when you install our tool, you will find a number of patterns. You can also find patterns as libraries in our website. If you go to our website and you click on the section of libraries, you can find, as I will show you, libraries including patterns, like the EARS patterns. EARS comes from the easy approach for requirement syntax, or you can also follow the patterns as described by Sophist. Sophist is a German consulting company that has released a lot of material about requirements patterns, and they have something that they call master Sophist patterns. So these patterns are also covered into libraries in our repository, right? So that when you write requirements on top of DOORS or Excel or Team Center, you can have these requirements automatically in real time check against the rules that you have defined in RQA, following the structure, the textual structure, the sentence structure, following one pattern that you can define in KM, and using the concepts from the control vocabulary that you are managing also in KM. And it is not only that KM allows you to manage control vocabulary, it is also that KM can connect also in real time to external models. So we can connect KM to modeling tools like Rhapsody, MATLAB Simulink, Magic Draw, Cameo, or even ontologies in Protege. So when you connect KM to an external repository, knowledge repository, it is not a requirement repository, it is a knowledge repository, then the native knowledge which is stored within our system knowledge repository and the content which is imported from this kind of external models is mixed in real time, so that when you write your requirements here, you can have the vocabulary coming from, for instance, from your model. So when I have to name in a requirement the name of one of my components, it can be that I can see in front of me in the screen, I can see the name of the blocks in a SysML model in Rhapsody, or if I wanted, if I am writing a condition and I say, okay, when the GPS is in whatever state, I can the name of the states can also be retrieved from the name of the states in a state chart in the modeling tool, right? I will try to show you this during the live demo. So these are the three tools that I will be showing you. In terms of connections to external tools, as I mentioned, in this table, this table includes 4 main blocks. This block is what we can do in terms of requirements quality checking, let's say. This box is also what we can do in terms of quality checking, but not for requirements management tool, but for other modeling tools that somehow can manage requirements, like Capella or Rhapsody. You can see here that we can do requirements quality checking in modeling tools, in Rhapsody or in Cameo, Magic Draw, right? And here, what you find is that we can extract knowledge or content from modeling tools, like I was mentioning before, so that we can connect to modeling tools and retrieve information from block names or classes names, interfaces, states, transitions, and so on and so forth. We can extract all this from UML or SysML modeling tools or other modeling tools like Simulink or the similar modeling tools, right? So this is the information we use to analyze the quality of the requirements. So the main focus is to analyze the quality of the requirements, all these blocks, but for completeness and consistency, mainly, we can also use information from models to leverage or to perform a more complete consistency checking, right? Then, this is just one slide to represent what is an ontology in our approach. If you already know the concept of ontology, probably you will disagree with us in the definition of what an ontology is. We are not claiming that this is the best definition in the world for what an ontology is, but at least we find that this is the one that better fits our purpose of analyzing textual content requirements in this case, and performing and providing quality tips and hints to improve the quality of the requirements, right? So similarly to what an ontology does, we start with control vocabulary, and we start by classifying in the second layer. We classify concepts by the nature of the different entities. So for instance, we can have GPS and engine as a component, while pilot is not a component, is a user, let's say, somehow. Or we can have relationships between the different terms or properties. So all this is in our second layer, in what we call system conceptual model, right? However, unlike other definitions of ontologies, we need to understand a textual statement, a requirement. So we need patterns, as I was introducing before, right? So the concept of pattern and pattern formalization, which is the transformation between a textual statement and something that can be understood by a computer, like a semantic graph, right? And this is what is the input for the reasoning. And in our tools for quality assessment, the reasoning is just to determine whether or not a requirement is meeting all the rules that are expected to meet, and if not, which one is the ones that are not the ones that are not met, right? Then we have created a number of different knowledge libraries following this approach. When you install our tools, you always have a knowledge library that is the one that we call out of the box. So this is the basic library containing elements at these 5 levels. So our libraries can contain vocabulary, of course, and can link this vocabulary elements or classify under different criteria. Our out-of-the-box libraries will include patterns and pattern formalization, and of course some quality rules. However, aside from the out-of-the-box libraries, you can also find some other more specific libraries, like a library implementing, I was mentioning earlier, the Inkosi guide for writing requirements with its 41 rules. I have to mention that we didn't manage to implement the 41 rules in our metrics. We have some rules more related to feasibility, and this is something difficult for a computer. So out of these 41, we have managed to implement 37, which is not bad. Then you can also find a library including the patterns as defined in ERS, in the easy approach for requirement syntax. We have also libraries including the terminology followed by the European Space Agency with the quality rules as provided by the Space Agency, and similarly for the NASA. We are working now in a library for the ISO 26062 for those of you dealing with the automotive industry. And then also the Master Sophist library that I mentioned before, including patterns and some quality rules as well. So all this is available in our website. So together with our tools, you can download these libraries to work with specific information from specific vertical industries, let's say, while the out of the box is not involved in any specific industry. It's not about it's not having specific domain-specific vocabulary, let's say, right? Then, as I said, we have taken the Inkosi guide as a reference, but we always like to tailor this because it is sometimes it can be a little bit tough to follow all these rules in the Inkosi guide, and our deployment strategy normally requires or starts by a smooth deployment of rules step by step, so not all the rules at one single step. So together with our library, we have released a book, 100-page book on how to tailor the rules in the Inkosi guide into our tool RQA and R80, right? So you will be given the recording of this session together with some links, for instance, to download this table. And the book, I think it is almost ready. It is not published yet, but it can be published in a matter of 1 week or something like that. So please contact me back in a week, and I will give you the opportunity to have a look at this book as well, right? Then more about the tools before I open the tool itself is that probably when you think of these kind of rules as to avoid vague adjectives or vague adverbs or to avoid this and that, you can think of a tool like a kind of keyword spotting, something like just looking for small keywords in a document, and that's all. So I have to admit that our tool is very far from this point. Analyzing the quality is not just looking for small sequences of letters conforming a word to be avoided in your requirements. In some cases, these are two fragments, two rules from the Inkosi guide of writing requirements. So, for instance, the rule 2 of the Inkosi guide is about the use of active voice, but there's a subtle point here, meaning use the active voice in the main sentence structure, not in the condition. So if you follow with the examples, then you will find examples where passive voice in the condition is not an issue. I will try to show you. Similarly, for avoid combinators, avoid things like and, or, unless, and so on. Look at this, excepting and or not can be used in need and requirement statement as logical conditions. So we have to be smart and in the detection of these elements, and we are, in fact, by using patterns, as I will show you. So this is a kind of example where you have a requirement that goes when the alarm is activated, the train shall be redirected to the closest station. In here, of course, you can find passive voice here and there. So technically speaking, or linguistically speaking, these both statements are passive voice. However, the tool is just telling, okay, one passive voice. Why? Because this one is part of the condition. So by means of a pattern, the tool understands that this block is the condition and this block is the main action. So only passive voice in the condition is harmful. The good news is that this is my personal approach, but if you don't agree with me and if you want to avoid passive voice wherever in your requirement, you just disable the rule or change the behavior of the rule. It is very easy as soon as you learn a little bit how to manage the three tools, it is very easy to modify the behavior of the tool so that the tool can analyze exactly what you wish. If passive voice is not harmful in your opinion, wherever in the requirement, you just disable the rule. If passive voice is harmful wherever, then you just modify so that instead of one, you can have the tool telling you two, right? So it is very easy to do so, right? Similarly, for this requirement, the rotor shall turn around the core at a minimum speed of around 70 revolutions per minute. Here, you can find around twice in your requirement. If you take a normal text part of a speech processor, then you find around in white and around in brown. It is meaning two different things. So it is playing the around two different roles in the sentence. So the same as you can find in this well-known part of a speech processor, you can find it in our tool. So in our tool, you can have the same sentence, right? And around appears twice, but the tool, similarly to the previous example, only highlights only one. Which one? The one that is actually harmful. Around 70 revolutions per minute is a vague requirement. It's difficult to measure. You cannot verify this requirement with this around 70 revolutions per minute, right? Okay, and all this is ready in 8 languages. This session is, of course, in English, but the tool is also ready in French, Spanish, Swedish, German, Italian, Japanese, and Dutch. So there is no need to have different installation processes for different languages. With only one installation, you can work in the 8 languages, provided that you download the out-of-the-box database for the different language. So you can have, as I do in my computer, I have a lot of different databases, most of them in English, but I also have databases in French or in Spanish, right? So you can do the same in your particular case. So that's all. No more slides from my side. So I start with a live demo. It will take us something like 30 minutes, so that we can have 10 final minutes for conclusions and for more questions. But if you have any questions so far, please don't be shy and don't hesitate to ask. If not, I jump back into the demo. Okay, I have one question. What about the methodology? What do you mean? Methodology of managing requirements, or methodology of managing the quality of the requirements? Normally, we together with the tools, we provide a consultancy to our customers, where we show our customers how to implement all this following our own methodology. So we do have a methodology. We are writing another book on this topic, on the methodology. This book is not ready yet, but I hope that summertime will be enough as to finish the book and publish this book on the methodology. Yeah, exactly. So your question was the methodology of working with our tool and to generate a specification. Yeah, as I said, we do have a methodology. It is not public yet. It will be very soon, I hope. So. RQA. Can you see RQA now? I have 2 screens. I think I'm sharing the right one. So this is RQA. Let me close it for a second, and let me go into the connection screen of the tool. So this is the connection screen of the tool. I hope the refresh speed is enough. So in here, the idea is that you can establish connections to different tools. I was mentioning some of them: IBM DOS, DOS Next Generation, PTC Integrity Lifecycle Manager, Rectify, OSLC, Excel, RecIF. So different formats, and some others that are not listed here. And since the tool RQA detects that I don't have all the tools installed, then they are not listed here. But we do have more connectors following the table of connectors that I was showing you before. So establishing a connection to a local file like rec.ie for Excel is as simple as first selecting the file, and second, mapping the columns or the attributes. This is the only tricky point a little bit. Connecting to a requirements repository is even easier. You just, for instance, in the case of this one, you just provide what is the name of your server. If you know doors, then you will understand that I have, for this demo, I have a doors instance local in my computer. So as soon as I provide my credentials and I say, okay, this is the version of doors that I have installed. This is my server. This is my port. Then the tool shows you the different projects. You click on one of the projects, and this will be the target of the quality inspection, right? I can force a particular database or ontology. In this case, I will use an ontology with some concepts about railway, right? So this is my connection. So now with a double click, now the tool is opening doors. Even if you don't see doors, the requirements repository, there is an instance of doors running now in my computer, and RQA connects to it and retrieves the name of 2 documents within this project. I decided to keep it short and quick, so there is only 2 documents in this project. I will start speaking about correctness, so I focus on only one of these, but of course you can select both or select all, whatever. But for correctness purpose, I just double click on one of these documents. And to have a quick analysis, it is a small document with only 80 requirements, as you can see here. So this is RQA. The first step in RQA is always to select a number of rules. But of course, I have been analyzing these documents a while ago. So this is why you can find out of these 80 requirements, 3 stars is meaning that, well, it's not that bad. And of course, 1 star is meaning, wow, this is something that we have to fix if we want to continue, or at least we are breaking some of the rules. As you can see here, it is as simple as just moving the mouse up and down in here in the definition of the different stars here, and then you can see the level of quality in this tooltip. For this requirement, the level of quality is 1 star, low quality, and the findings are, remember, I mentioned that I don't want to have should. I always write requirements with shall, so I have established a rule to detect that there is 1 shall and should is forbidden. So this is the first 2 items in this bullet list is first warning about the use of should and telling me that shall is missing. Then imprecise quantifiers like in this requirement, very is of course forbidden, or many, so or as possible. So all this is forbidden. And the last one was quick. Quick is not welcome as well, right? Of course, I can just double click on my requirement, and then I see my screen, my RQA screen here. Here you can see all the rules that has been analyzed. So this is the list of rules. I don't remember the number, something around 30 rules or something like that. And out of these rules, there are 4 issues. So as soon as I click on any of these issues, then the tool can highlight for me, okay, the issue of the use of a should. And as I mentioned before, the idea is to provide some tips on how to improve the quality of these requirements. If we agree on the use of shall, should, will, whatever, then as soon as you click on one of your concepts, then you can see, okay, modal, compulsory, should is used to indicate whatever, and shall should be used. For the rest of the elements in the specification, you can also see the description, the structure in the product breakdown structure, and so on and so forth. So I just move my mouse on top of a train. So I hover the mouse on the word train, and the tool is telling me that train is in the cluster, in the block of a system. It's a system name. concerning the PDS structure, the composition structure, it has children like a car body or car body fitting, guidance, power system, propulsion system, auxiliary system, braking system, interior, blah, 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 blah. And what we call the scope note is a definition. What do we understand in this project out of the concept of a train? What a train is for us. A train is a form of transport, blah, blah, blah. So all this is in front of you. Not only the number of issues that you find, but also the definition of the concepts. Of course, when I click on something like avoid imprecise quantifiers, then you can see, well, avoid quantifiers that cannot be easily verified. Don't use very, use a more accurate amount. Or if I click on quick, the tool tells me don't use quick in a requirement, please provide a more specific speed, right? So this is the way the tool can help you. Of course, if I follow these tips, I can improve the quality of my requirements. Hopefully, having my requirement in green, so this red frame is meaning that something is not as expected in this requirement. You can have a lot of information here. Of course, for the beginners, normally the tool is something like this. So there's no need to show more additional information. So with this is enough, let's say. And as soon as you can manage to fix the defects and have this in green, you can save back in your requirements repository. So as I explained, RQA is not a tool to manage the requirements. The requirements are still managed in this particular case in doors, in IBM doors. However, if I fix the quality of this requirement, I can still save from here, right? In my case, I will not change anything, just not to break the course of the session. This quality can be exported in short reports, in full reports, in a customized report. So it is quality report. So it is very easy to provide even customized reports of the quality of your requirements. So a chart of the quality, all the different metrics, which metric is impacting the most in your projects, what metrics are not impacting at all in this document. And here you can find all the findings. So for all the requirements that are having at least one issue, it could be correctness or consistency issue, then you have the requirement and the issues that have been found, right? So this is the report generated by RQA. Of course, I can using RQA, I can see what is the current level of quality of my document. Not only the correctness correctness level, but also correctness, consistency, completeness, so the overall approach and the overall status with regards to quality. I can take snapshots of quality, so measuring the quality of given times, moments in time, so that I can, by means of this capability, I can have a report, a progress report like this, telling you how quality is performing in your project from the first day until today. So you can record as many snapshots as you wish, right? So I go back to the level of quality. So what can I show you here in terms of quality? For instance, the idea of passive voice that I was mentioning before. So for instance, this requirement, just to show you how smart is the detection. So this is what I was mentioning. Clearly in here you have you can find should be redirected. This is passive voice. However, in fact, there is another passive voice here, but this other passive voice is normally is not that harmful because it is part of the condition. So this is not I just configured this set of rules just to detect passive voice only for the main action and never for the condition. So this is why even if there are two passive voice statements here, only the second one, which is the main clause, is highlighted as passive voice. What else can I show you? Oh, this one. So this is another interesting requirement. So in here, first of all, the tool is telling me that I have a wrong assignment of a unit for a given magnitude. So I'm speaking about the length of the antenna, but for whatever reason, don't ask me why, I was given the voltage and not the length, right? So this is given here. If I just change this value and then write voltage, now even if the requirement is dim as green, there is still one issue, which is coming with the tolerance. Regarding the tolerance, I can do things like I set to my knowledge base that I wanted for the voltage, I wanted always to have a tolerance. So if I remove the tolerance, then the tool is telling me, wow, there is something wrong, there is something missing, missing tolerance in this requirement. If I write the tolerance, it could be with the symbol plus minus, but since I don't remember this symbol now in the keyboard, I will write tolerance like plus minus. The tool work on this for you. Then now the missing tolerance disappear, but I have a message telling me that the tolerance now is 90% of the nominal. So this is too much, let's say. So this is why the tool is complaining. If I give a value which is too tight, as I said, 0.05, then the tool is complaining again. So it is making something like 0.2%. Now it is too tight. So only when I write something, something like this, for instance. Yeah, now the quality of this requirement is high quality. So this is kind of the idea behind the tool. Of course, many other rules that you can implement, like vague actions or connectors, negations, the should, the shall, short requirements, long requirements. So this is what you can find in RQA. If I move now to the with regards to correctness, I am starting with correctness. I will be mentioning consistency and completeness in 5 minutes. So if I now go to the last part of the tool, is where we can manage the different set of rules that I have been using in analyzing the quality of this requirement. So in this database, of course, I have a lot of different set of rules, and 14 set of rules. Probably if you download the out-of-the-box version of our database, you will find only one set of rules. If you download different libraries from our website, then of course you will be gaining more and more set of rules. If I open this one, this is the one that I have been using for my document. Then you can find that there are 27 rules that are enabled. You can filter to show only the 27 enabled. So for each of the rules, we have rules of different nature. We can implement rules based, by the way, on information from the requirements management system. Like I want all my requirements to have a particular value in an attribute, or I want requirements in this document to be traced up to another requirement in a higher level document. So this is the kind of information which is not concerning the textual part of the requirement. It is concerning attributes, links, or versions, or whatever. However, for the rest of the metrics, the most advanced metrics, they are about or they are assessed after semantic analysis of the textual part of the requirement, right? Incorrect spelling, I didn't mention, of course, but please avoid incorrect spelling in your requirement. You can analyze this incorrect spelling with our tool. Readability, we have implemented the most typical algorithms for readability, so that when something is not easy to read, then you can have a warning, passive voice, conditional mode, imperative mode, terms out of the level of abstraction, terms not defined in the dictionary. So all these are the rules that, of course, I will not cover one after the other. You can download our books, and you will learn more about the number of rules that you can implement. Then in here, you can see what are the patterns that we are expecting to use when writing requirements. So for the documents following this set of rules, I have also established a number of different patterns. The patterns are defined in here in pattern groups. And then for each of the metric that you can define here, it comes a quality function. What is the purpose of this quality function? Normally, every metric is providing you with a quantitative value that has to be transformed into a qualitative value, right? So this is why we are using this quality function. So for instance, one that could be very easy to understand is the text length, this one, where the quality function is telling you that something below 3 words is too short as to be a requirement. Something, in my particular case, something from 3 to 26 words is okay for a requirement. From 26 to 50, it is starting to be a little bit too large, and from 51 on is definitely too large, right? So this is a quality function. Normally, the quality function is very, very easy. So for instance, avoid connectors. 0 connectors is okay. 1 or more is not okay. So normally, the quality function is what I call binary functions. Something that happens is okay, and if it is not happening, it's not okay, or the other way around. So it is as simple as that. Binary, only 2 levels. But only, for instance, the text length can be analyzed like this. And if I am correct, also, for instance, the number of shall. For instance, I want at least 1 shall in my document, but if I don't know where this metric is, probably this one. Okay, perfect. So 0 shall is not okay. 1 is okay, but 2 or more is not okay again, right? So this is not a binary function, but it is also very easy to understand, right? So this is the approach. You can define quality metrics that provide you with a number, how many instances of this metric has been detected, and then by using the quality function, we transform this quantitative value into a qualitative value, which is representing the quality for my document, right? So all these metrics are the metrics that I have been analyzing here. By the way, I forgot to mention this very important part of the tool. In this part of the tool, after the analysis, it is not focused on the requirements document. It is focused on the metrics. So this table is not showing you requirements. It is showing you metrics. So that very quickly, if you sort the metrics by the impact, then you can find that the one which is impacting the most in my document is one metric to detect over specification, let's say. So this is what I mentioned. This document is intended to be the requirement, the system requirement document for a train. It doesn't mean that I cannot use terms that are in the. Let me show you. By the way, let me show you another tool, which is the Knowledge Manager tool. It's in my other screen. So this is the knowledge base that I'm using to analyze the quality of this document. This is my train. Remember the idea that I was, remember what I was showing you about the definition of what a train is, the clusters or the classes this term train belongs to, the relationships with other elements. So all this information is coming from the knowledge base, right? Including the decomposition of the train. This information can be managed natively in KM or by using what we call the extensibility mechanisms and the knowledge interfaces. You can have connections to modeling tools, for instance, or to Excel sheets or whatever, where additional information can be found to analyze the quality of the requirements, right? For the time being, I keep on KM. As I said, this is the structure, and the document that I am analyzing is the document for the train. So I have established a metric to force the subject of all the requirements to be the train shall, and never the braking system shall, for instance, because I will have another document to specify the requirements of the braking system. It is not meaning that I cannot use the concept braking system, but it is meaning that if I use the braking system shall, as I said, the tool is telling me that something is wrong. So breaking system is not okay when it is the subject of the requirement, but of course breaking system is okay when it is part of the requirement, not being the subject of the requirement, right? Of course, for each particular metric, you can see what are the findings of the metric. You can see all the requirements, but now this quality column is not the overall quality for my document. It is the quality concerning this particular metric. So this is telling me that only this, you can filter, you can sort, so only these 16 requirements are not meeting this rule, but this 16 is making this rule as the most, let's say, challenging rule in my documents, right? So this is the detail about this metric. Of course, you can go and see other metrics that are impacting in the quality of my document. The use of imprecise quantifiers. I'm using on purpose a lot of any, very, many, approximately. So all this is something that normally is not welcome. The use of shall and will. I have some issues as well. Vague adjectives, passive voice. Remember the intelligent detection of this passive voice. So this is the idea of behind the quality inspection, right? So as soon as I establish the set of rules in what we call orange belt, then you can come to this section of the tool project configuration and say, okay, for this document I want to use the orange belt tool, while for instance for this other document I keep using the white belt, right? For instance, this is something that you can do at any moment. Then if you get into the details of the configuration, you can enable the option of save the quality assessment not only in our database but also in the target requirements database in DOORS. This is a kind of trigger as well to analyze the quality in DOORS in real time, even if you don't open the RAD tool. You can filter. Normally in my document, all the objects are requirements, but normally in a normal document, you will find that some objects are requirements, while some other objects could be headings or comments or rationales or whatever. You can establish filters by using different criteria. For instance, you can establish filters based on a particular condition, like here, or in the case of DOORS, you can establish a filter based on a particular view in DOORS. So different options that, of course, we cannot cover in this session in detail. So when I go back to my requirements, since I have changed the configuration of rules, then I have to reanalyze again. Reanalyzing is very quick. There are only 80 requirements, and it takes some few seconds. As you can see, most of the time is not on analyzing the quality. Most of the time is on saving the results back in DOORS. So the result is the analysis is already done. Now it's saving, and it is now analyzing consistency, which is a little bit more time consuming. And that's all. So now I have the results again of my documents, and this result is stored in DOORS. So of course there are plenty of other options, but let me jump into DOORS. So now this is DOORS. So far I was showing you RQA, the tool for the quality inspection, or for managing and setting the set of rules. Now I will focus more on the second tool, on the RAD tool. So the RAD is the tool for the authors of the requirements. So now I have opened DOORS, like my requirements repository. I click on my project and I see the two documents that I was showing you before. So as I double click on one of my documents, the one that I have analyzed, then I find my 80 something requirements in here. So this is DOORS, typical DOORS with the standard view. However, since we have installed the authoring tool, then there are a couple of menus that appears in the screen. So the authoring menu, this is coming after the installation of the RAD tool, and this authoring option here is also coming after the installation of the RAD tool. Then also with the installation of the RAD tool, you can create what we call a quality view. If I click on the quality view, then I have exactly the same number of requirements, but remember that I check the option in RQA of storing the results of the quality analysis back in doors. So it is meaning that when I analyze the quality in RQA, the RQA will be creating 1, 2, 3, 4, 5 columns, 5 additional columns in your DOS module, including the level of quality. Instead of using 1, 2, 3 stars, we are using here a color code with high, medium, low in green, yellow, and red, but it is exactly meaning exactly the same as in RQA. And what RQA is showing you with this tooltip, something like avoid can and missing auxiliary verb, for instance, in this requirement. In here, this information is shown in this column. But in any case, the information, as I said, is presented in a slightly different way, but it is exactly the same sort of information. So it is making, of course, when you can enable the trigger option in doors, making that if I write a requirement as I normally do, you can normally do in doors, then the system shall be designed to be very flexible, whatever. Then I expect now that the tool is telling me that very is not welcome, flexible is not welcome. So this is the kind of information that can be given in real time. But if you want to know more about the details, then you can edit this requirement with our RAT plugin. So now this is the RAT plugin, telling you, okay, this is the text, and these are the 4 elements that has been detected. So passive voice, very is not welcome, as I was telling you, it's not welcome. Vague adjective, and it is not conforming to the structure of this type of requirement, right? So the idea is that you can follow patterns or not. I will disable the idea of pattern so far, and you can completely rewrite this requirement. So as soon as you start typing, you can see, like in here in the right-hand side of the screen, everything has changed. And now I'm not informed that I am using passive voice or flexible or whatever, but the quality is still low. Even when I remove everything and I start from the beginning, the quality of the requirement is low because there is no action, there is no imperative, and it is too short. Remember, my requirement has to be between 3 to 25 words. So these are the 3 issues that has been detected. So as soon as I start typing, the speed of the train shall be whatever. Then you can see like everything is in green now. But now I type 333. It's a number without unit. So this is the issue that the tool is detecting, a number which is not followed by units. So if I continue and I say, oh, okay, let me do something wrong, kilograms, then the tool tells me, oh, kilograms is not good for the speed. So okay, let me go to kilometers. Kilometers is not good because this is not a speed unit. But if I go kilometers per hour, then this is now green. So I can save and close, right? So this is the kind of things that can be done in the tool together with many of I can create using the shortcut. I can create more requirements from scratch. So the radio and the antenna shall both be made of hard plastic. Of course, misspelling detection highlighted in the tool, plastic, and the rest of typical elements, the connector, imprecise quantifier, ambiguous universal. So all these things that you could be expecting out of a wrong requirement. This is a non-atomic requirement, so of course the tool is telling me that something is wrong in your requirement, right? So this is let me move a little bit forward because I am running out of time. So more things that you can do with the tool is you can create a new requirement following patterns, right? So what is a pattern? A pattern, by the way, the patterns can be defined in KM. And if you remember, when I went to set up the set of rules for this particular document, I also established a subset of the different patterns to be available for these documents, right? So that when I go back to my RAT here, you can find the different types of requirements, system functional. So these are the types that I have established in the RQA, and if I want to write a physical requirement, then I click on my pattern. You can see what is the structure of the pattern. So these colored boxes is representing the structure. So it seems to be a little bit difficult to understand that at the very beginning, but after a couple of requirements, then you will quickly realize that the blue boxes are representing classes of elements in our system. So physical property and a component. This is what I want to write. I can see examples of this. I can see the purpose, examples. An example is the length of the antenna shall be 11 centimeters. So this is the kind of requirement that I want to write with the RAT. And then when I enable the writing assistance, you can see like it is not only that the RAT can show you the structure of the pattern, is that the RAT can connect the structure of the pattern and the dictionary, so that as soon as you keep typing, the elements that are fitting or into the next step of the structure, the pattern, are shown in the screen. So you remember the first blue box was the name of a physical property or physical characteristic. As you can see here, all of these 21 elements are physical characteristics, right? So these are the 21 entries in my dictionary under the block of physical characteristics. So I keep typing the weight. As soon as you type a couple of letters, the list is reduced with only those elements starting by, in this case, WE. So you can press the tab key. The weight of the, now the list is a little bit larger because the following blue box was a name of a system element or system in my dictionary. So I can write something like the weight of the train. Then after the train shall be, and then a number. I can write something like and then a measurement unit. Now the tool is telling me, again, remember that a number has to be followed by a measurement unit. Of course, if you make a mistake with the selection of the unit, the tool will tell you. If I write pounds, then you can now see this green frame. This green frame is telling me that this requirement, as it is today, as it is now, is fully fitting into this structure. And then optional maximum minimum, this is optional. Then the property of and then the component shall be, and then a number, and then a measurement unit. This is exactly what I wanted. So this is this green frame. And this other green frame is telling me that everything is correct. From the correctness standpoint, this requirement is also correct. So I have to be a happy guy now because everything is okay or seems to be okay. However, if I go to consistency, remember the 3 dimensions: correctness, consistency, and completeness. Consistency is a little bit more time consuming in the analysis. This is why it is not analyzed after every keystroke as the correctness in here. But for this small document, consistency is pretty much quick. So now in 3-4 seconds, you have the consistency analysis from this requirement against the rest of the requirements in the document or against the content of the ontology, as I will show you. So the tool is telling me that, wow, I'm using pounds in here, but the tool is telling me that there are other requirements written in kilograms, and this could be misleading the readers of the requirement. So when I open, the tool tells me that for this metric, 80% of the requirements in this specification are okay, but 20% are not okay. So I can click on the ones that are not okay. Of course, the first one is the one that I'm writing now, in conflict with all the requirements in my spec, in conflict with these 2 requirements in my spec that are used in kilograms or grams or whatever, which is not in the British imperial system, let's say, right? So of course, the tool is not forcing you one system or the other. The tool is detecting non-consistency in your requirements. It is not forcing in any way, right? So if I change this and I write, let's keep it as it was, because there is another issue here, which is an issue with a property in the ontology, right? If I go to my ontology, if I select the Knowledge Manager tool again, and I go to my train properties, then I have a property here saying that I expect all the trains in my company to be between 500 to 600 tons, right? In this requirement, I said 400,000 pounds, and the tool can transform this number of pounds. It makes 198 ton, which is far from this value of 500. So I change this into 500. I change this into kilogram, and now I reanalyze again. Remember, it is not consistency. Consistency is not automatically analyzed, but it takes 5 seconds. And then I have everything either in gray, meaning there's nothing about signals in this requirement, so it is gray, or in green. There could be an issue, but the issue is okay. So there is no more issues in this document, so I can save and close, right? So now let me show you something about completeness. Completeness is, by the way, the most difficult dimension, not only for humans but also for the tool. It's difficult to know when you are done. One requirement more is meaning that something is duplicated, something is over-specified, something is out of the scope, whatever. And one less is that you are missing something important in your specification, right? So it is very difficult. So the idea is that what we do is we compare what we can extract from the specification against what we have in a model or in an ontology. In this particular case, I have 12 completeness metrics. I will focus just on one of them, which is the power consumption, the allocation of the power consumption. So what I did here is that for a very small branch of my ontology, the air conditioning, this one, which is only 5 elements in the branch, I want to have a power consumption given for each of the different elements in my document. Normally, this will come in different documents, but remember that this value will come or this requirement will come in different documents, but remember that you can select a full folder or project or as many documents as you wish so that you can perform this analysis. And the tool tells me that out of these 5 elements, the 80% means that out of these 5 elements, for 4 of these elements, there is a value for the power consumption in the specification, but there is one which is missing, which is the root of this branch, let's say, the air conditioning itself, air conditioning system itself. So if I go back to my doors, I can create one more requirement. I select my pattern and I start typing. Then now the element, the air conditioning system, now the property, power consumption. You can use the cursor keys or the tab key, whatever. Shall not exceed, say 1.1 kilowatts. Now everything is green for the correctness. Let me focus on consistency one more time. And when we analyze consistency from here, now there is one metric which is in red, and this is an allocation metric. So the tool is, I said 1.1 kilowatts, but the tool is telling me to do something over or to use a value over 1.23. Why this value? And I can double click and see the details. If I go to the PPS in here, so this is my element, this is my branch, and the tool is now, the RQA is now connecting to the repository, to the ontology, to see what is the structure, the physical structure for the air conditioning system. So these are the sub elements in the system. So the tool is taking the actual. Sorry, I have lost my screen. Okay, now I have 2 screens, and sometimes the screen jumps from one place to the other. Okay, this one. So the tool has taken the actual values in the requirements and said that I have one requirement saying that the power consumption for the heater has to be 6 watts. For the fan has to be 1.2 because the fan blade is having a value of 400 watts. But remember, the structure is telling me that there are 3 fan blades, so it is multiplying 400 times 3 is making 1.2. So it is aggregating the values, it is transforming from kilowatts to watts and so on and so forth. And all this together, it makes 1.23. So this is the value that is given to me. So of course, not always the idea is to change this value and say, okay, this is okay. The tool will not help you and say, okay, the value you have to change is the value for the air conditioning itself. It could be that the value that you have to change is the value for one of the sub-elements in the tree. Of course, the tool is not giving you this information, but at least it's telling you, please double check this for the allocation of the power consumption. I decided in this particular case to change the value for the air conditioning system, and now everything is in green, right? So this is the idea. I have covered correctness, patterns, consistency, completeness, the RQA, the tool for the quality inspection, and the tool to set up the set of rules. And also I have covered the RAT plugin on top of one of the most common requirements management tools in the world. So I think that I covered everything I wanted to cover. So I give you some minutes for questions. Okay, I have one question here. Can you mix knowledge libraries to create your own custom rule set? Yes, the answer is yes. You can take, for instance, the patterns from the ERS library with the quality rule from Inkosi, and you can blend all this together, and you can extend the number of patterns, reduce patterns, modify patterns. You can create your own rules inspired by the rules from Inkosi or inspired by the rules that you can find in our out-of-the-box database. But at the end of the day, of course, yes, you can create your own rule set. This is the idea. The idea is never for the tool to force you in any particular way, even if I like the rules that I have been presenting today, of course. But it doesn't mean that these rules will fit any single project, right? So you can, of course, customize your rules and apply different rule sets for different documents, for different projects or different teams. Yes. Any other question? In any case, if you have any further question that you can ask or you don't want to ask today, please don't hesitate to send me an email with your questions. I will be very happy to contact you back for a quick answer in an email, or to set up a call, a WebEx conference or Teams conference, whatever, just to have a deeper explanation. That's all. So thank you very much. Take care and enjoy the rest of the day. Bye for now.